Okay, let's work on the next symbol, which is the Cancer symbol. I should change this to be Cancer, which is a crab, I guess, according to what I looked up. Now it's like a stylized 69, which I guess represents a crab somehow. I don't know why, but we're gonna draw it. So, as I was kind of like looking at images, I was trying to think of like, well, how are we gonna do this code? And I think that the Cancer symbol could be kind of geometrically made as like 3 circles, and then with some cropping. So, first thing we're going to do is just duplicate this section of code. And then anywhere we see Gemini, we're just going to replace that with Cancer, right? And I know that's kind of like hackish, but it's hackish, but it's also kind of like, what do you call it? Explicit and dead simple, right? Keep your code dead simple. So rather than doing some weird kind of like framework kind of thing, we're just doing this. Okay, so this isn't the cutting sheet, but we want to actually work on the code, right? So for the Cancer code, we're just going to say Cancer code right up here. We're just going to add it, stack it onto the top. Okay. And we're going to name it in the same naming convention as everything else. So it's going to be ZOTCOM Cancer. Takes an SBC object, which stands for shopbot constants. Right, so we're trying to write it in a way where it's kind of flexible. So if we want to use this file in another shopbot project and want to combine code from two or more shopbot projects, we want to keep this kind of SBC format of this object kind of the same. There's not really objects in OpenSCAD, as I am aware, so it's just an array, and all the elements in that array have to be arranged in a very specific order if this object is going to be compatible across all shopbot projects. So we're going to try that. We're going to try really hard to see if this lasts, but you know, most of my things end up being for the laser cutter, but I want to branch out eventually. Because the laser cutter, you can only do so much. So within here, the first thing we're going to do is, before we kind of like do anything, we're going to find that wheel code for a second. And this wheel frame code is kind of like, we need this, we need to use this temporarily so that we can see what it looks like, right? We want to know what that wheel frame looks like. And we also want to take this here and run it as well. So these 2 lines of code on lines 76 and 77, they're going to be deleted once we're done. But we just need something in here now to kind of jerry-rig this together to verify that it is correct, that it's to the scale we want, and all that good stuff. So let's go top view, let's zoom extents. Okay, so we have this. We're ready to draw a symbol in the middle of that. So like I said, we could probably do this with a circle and a circle. And so the easiest part would be to do that outer circle. So I don't know why we're kind of stacking these in the inverse order, but I guess let's keep it up. So I think it forces me to look at the other constants I've already defined. So Cancer symbol consts, right? And then within here, we'll add the constants for the Cancer symbol, right? So I don't know exactly what constants we're going to need, but we'll probably need some type of circle, right? So we have 2 circles, right? So we have like a Zot Cancer imp imprad big equals, I don't know, 3, and then Zot Cancer imp rad small equals, you know, I don't know, 1. So just try something like that. Actually, maybe 0.5 might make more sense, and this might actually need to be like a 2. I don't know, we'll just take some guesses and then see if we like it, you know? So the big circle is what we're going to do first, right? So we're just going to say we want to use a V-carve inch circle, but it's not a circle. It is a hole. It's not a hole. No, it's a wheel. So SBC. So the values we use in here are a little bit different because I'm trying to differentiate between filled and unfilled primitives. So instead of a circle, there is a hole or a wheel, but there's no such thing as a circle in this code because of that. So that circle will have this radius, and the thickness that is going to be on here is going to be the thickness of the zodiac sign. So this is the zodiac sign's thickness. Thickness of zodiac signs. Right, that's what this is right here. So, right, so this is a kind of a wheel thing, and it has a thickness, right? So a lot of these new kind of shopbot things have thicknesses. Okay, so if we give that a run, right? There we go. So that's actually pretty decent, right? I kind of like that. It's very, it's not too close to the edge, but not too far away. In fact, this thickness right here seems to match this thickness, so it's a nice, happy coincidence. I'm going to say that is the perfect radius. I think we have solved that part. And so the next part is we want to kind of put these circles in here and to create the 69, right? So to create that, we could do like something really simple, right? We could just do, let's work on the first circle, right? So first of all, let's just take this. Let's take this and just get the first circle drawn, right? So this is going to be the small circle, right? And F4, right? And we can look at that and say, is that too big? Is that not big enough? I'm thinking that we want the thickness here to maybe be twice the whatever this is, right? Just so that it looks better. I don't know. So for that to happen, if there was no gap here, then the radius would just be the thickness, right? So we need to do thickness plus thickness, yeah? Yeah, so this smaller radius would make more sense as thickness plus thickness, and the thickness here is this, and that's ends up being 0.5. So basically we're going to make it thickness times 2, right? And F4. That actually looks too big. Well, I don't know. Yeah, that's too big. Times 1. Okay, so that's too small. The other one's too big, so the compromise in between is like a 1.5. That actually looks better, right? It's still going to be kind of bulky, though, but let's just give that a shot. That looks like a pretty good size. And we're just going to try to move it up by its radius, right? So we're going to try to go something like inch. Or actually, you could move it to the left, right? We could move it to the left, move it to the right. So inch y, SBC, okay, 0 minus this radius, right? And we're just going to move it over, right? And we move it over. Wrong way, inch x, my bad. When we move it over, we actually want to... looks like to get this all the way over, we need to move it by the thickness as well. And if we do that, then it will overlap perfectly. So minus this, and then minus the thickness. So the thickness of a zodiac sign line. Okay, and if we do that, F4, yeah, we have this complete nice overlap. And then what I'm thinking is we just we just have to cut it off somehow appropriately here. To make a line that kind of cuts that, we're going to have to think a bit, but I think the easiest way is... Okay, so we have this kind of already in place. So we're going to say, we're going to create a thing, and we're going to say, the small circle x equals this math here, right? That's Sx. F4. Okay, so the y is just going to be 0, right? We didn't move it on the y, right? So Sx and Sy is just a 0. Okay. And it's just important to keep track of those coordinates. So now what we can do is we're going to take this and... Well, actually, no. Yes. Okay. So we're going to take this and all this, we're going to do... Let's just do a union between this and a union between all this stuff. Okay. So hopefully no syntax errors yet. Ooh. We have introduced some mistake. And I don't know where... Gotta write a little code. Oh, this IX. When we pasted this IX, I don't think we did it correctly. Okay, paste that there. Okay, F4. Okay, so now we're gonna put this inside of a difference. And it's not going to be correct just yet, but I'm expecting it to erase this circle and leave it right because it's overlapped, right, like that. And now what we can do is we can make that circle. We can expand it by the thickness, right? So we want the circle to jump over this thickness because we want it to trim off that part, right? So this thing right here. So we just want to add the thickness, right? So we want to take this, keep that thickness, but then we want to increase its radius by that same thickness, right? So this looks kind of repetitive, right? But if we do that, F4, then you can see we have this perfect circle here, and we have these subtractions here, right? And so we want to, we only want that on the top. We don't want it on the bottom, right? So in order to get that working, what we can do is we can do a difference inside of here, right? So difference, and we can use that midline, right? We can use that midline to figure this out, right? So we're going to take the difference of this and a V-carve inch pocket, and it's going to be like, well, first of all, IX, SBC, and it's going to be like 0 minus rec height. We don't know what this is yet. And let's not forget this. Okay, so we didn't change anything just yet, but let's just make sure there's no syntax error. Okay, so rectangle height doesn't exist yet, which is a problem, but we'll define that right now. So, you know, let's just make rectangles, yeah, rectangle height. Width equals, I don't know, what is this? Is this like 3, 4? Let's just, it doesn't really matter. Let's just make it something big enough. We could just make it 5.25. And then the rec height needs to be, well, we could just make it both 5.25. That's fine. And then when we make this rectangle right in here, right, it's a VIP, a V-carve inch pocket. It takes SBC, and it takes the rec width, which is in inches, and it takes the rec height, which is in inches. And I think it takes a thickness variable. We're not going to use the thickness, though, okay? So, F4. And not what I was expecting. I was expecting something. Oh, so this is on the X, so we moved it over. So this needs to be on the Y, right? We moved it by the height, so of course that would need to be on the X. I don't know why I didn't do that. So if we do that, nothing. Nothing happens, huh? So the first thing is why? I don't know. Oh, this is too far down. No, it's not too far down. It needs to move down half of the width. We're trying to get it on the midline, but instead we've just overshot. We've overshot. Okay, so do that. That should work. F4. There we go. So now that's the wrong side, though, I believe. Or is it? I don't even know. Top view. Why does it look like that? I was expecting the... Not what I expected. Oh, we're erasing the eraser. Got ya. We're erasing part of the eraser. That's why. Okay, so put it over there. That's fine. Okay, right. So now we have something like this. And now that that's there, we can right, so the idea there was that if we get rid of this for a second, right, we get rid of this whole thing, what happens if we don't do this? It does it on both sides, right? And then we don't have a 6, right? So we have this whole circle that's erasing. Eraser ring. So this is like an eraser ring right here. Here. And that's good and all, but the problem is that it's erasing too much. Now, if we don't want it to be such a difficulty, right, where we have to, like, do more work later, right, because now we have this thing here, but it's like the 6 is way too big. It might be easier if the ring is big enough so that it gets past this midline. Once it gets past that midline, we should be in a good place. So this eraser ring is, this is the wheel. And so let's just make this thickness times like 4 or something ridiculous, right? If we make that thickness a little bit bigger, oh no, because it hits the other stuff, doesn't it? What if we do times 4 and times 4 like that? Now I'm just guessing. Times 2 maybe. It's actually pretty close. That's like a 2.5. Right, okay. And then what we can do is we can... Now, this obviously looks kind of nice, but the thing is we have to cut it here, right? Or actually, we have to cut it a little bit higher. We got to cut it like a... we're looking at the 6 and 9. I'm thinking we just strip it right here, right down in the midline. And then we can add a rotation later. Because this circle needs to start here. Or we could do a slight angle. Well, let's just do that now. Let's, is that correct, though? Yeah, that's correct. Okay. So we're not going to worry that we kind of guessed at this math, because as long as it looks correct, as long as everything is correct, we're not going to do this. We're not trying to do things completely parametric, where we can change things dynamically later, because it's just like, we're trying to just figure out the math for the one symbol, and it's never going to change once we like what it looks like. So, that looks pretty good. We just need to make like an angled line from like, well, first we can do a little box to chop this off, right? Then we can use like an angled triangle to chop off even more. So that's what we'll do. So the eraser ring is this thing. And then we'll just call this, this is a lot of work already. So we're going to call it untrimmed 6. I'm going to take this and I'm going to say ZODIAC Cancer untrimmed 6. That takes SBC, right? And then what we'll do is we'll just make another function in here called ZODIAC Cancer untrimmed 6 that takes SBC. And within here, we're going to take that code we've already written. Right, all that code we already wrote. And we're just going to shove it in there. Okay, so now, go F4. Unknown module, because this needs the module keyword. Okay. Okay, so now if we look at this, it should look the same. Unknown module, ZODIAC Cancer, untrimmed. I don't know why I wrote size instead of 6 here, but copy this. Go over here, paste. Okay, I don't know why I wrote, I don't know what's up with that, but okay. So now we got the 6, we know it's kind of in its own thing now. And now we're just going to trim it, right? So we're going to go difference. And we're going to trim it off right here, and then we're going to do more trimming later. But we're going to hack it piece by piece here. So we know we need a V-carve inch pocket. And that pocket could be like, I don't know. Doesn't really matter. SBC, we do 5, 0. And then just translate that pocket a little bit. So to the bottom, to this bottom quadrant. So IXY inch XY takes SBC, and then we want to move it 5 divided by 2, and then 0, 5 divided by 2. Okay, and if we do that, nice and trimmed, right? Now, if you see, this takes up more than half of the space, right? So we're going to have a collision if we try to rotate this radially and put another one in there, right? So we can't get away with just this. So we need to trim it again. So we're going to do a difference of this thing with another trimming rectangle thing. And this time we'll make a polygon, okay? Points equals, and we're going to fill out this polygon out with a whole bunch of points. And also we need to close this. Okay, so it's a polygon with no points. I think it'll complain, but I don't think it'll crash. So now within here, we want to say we just need to work on the angle, right? So this is 0, 0. This is some type of angle, and then this is like so this is like 0 degrees. This is maybe 45 degrees. 45 degrees would be good if we could get that to give us something decent. So 0, 0, and then we want to do right? So we want to get ready to make this. So within here, we need like some trigonometry, right? So cos of we're gonna go counterclockwise. So we'll start with cos of 0 degrees times DST. We don't know what the distance is. And then plus imperial to native units conversion. And then duplicate that for a second. And then we won't need the sine of 0. Right, so the angle is 0 degrees times the distance. We want to convert it, right? So impnat. And we can go look for this and just steal it from where we already got it before, right? So look, we did the same thing with some trigonometry earlier. And we're doing some more trigonometry, polygon stuff. So let's put the conversion thingy up at the top. I like to keep the geometry rendering and the variable setup a little bit separate. So then for this point here, instead of 0 degrees, we're going to do 45 degrees. So we're going to start here, then go over here, then go over here, but we need to figure out what the distance is. So how about, try DST equals, I don't know, 5 should be fine. And then this try distance is going to be here. So this is try distance. And let's give that a run, and hopefully we didn't introduce any mistakes. Okay, so that's pretty good. Now, I don't know if that's good enough, though. To know if it's good enough, we have to... first of all, we're going to steal this and just put it into its own thing again, right? So we're just going to... Well, actually, no, let's not do that. Because all we got to do is... Well, actually, yeah, let's... So, all we got to do is mirror it... mirror 2. So we're going to make 2 of them, and this, when I say mirror 2, I mean it's going to be a radial mirror. And I'll take SVC, and then we're going to go find where we did the other mirror code. So we have like a mirror 12 somewhere in here. So mirror 12. Right, so we got mirror 4, right, and now we're going to do a mirror 2, right? So mirror 02. And the mirror 02 just needs two of them. The first one can be rotated 0 degrees, and then the next one can be 180, right? So, because they're just across from each other, right? And if we didn't make any syntax mistakes, then bam! Not too bad, not too bad. I think that, maybe this is a little bit close. It's a little bit close, but the other thing is that I really like the fact that it's a 45-degree line. Like, the 45-degree line, so that means this kind of, woof, lines up very nice. I think I might stick with that, just because it just lines up nicely, right? Though this is a bit close, though, isn't it? But what is this? This is a 1/2 inch right here, which makes this probably about a 1/4 inch, which isn't totally unacceptable, but it is a bit close. We could... Here, let's change the angle for a second. If we change the angle to something else, so where is our angle, right? This 45. If we make the angle, say, like 30, let's try 30 for a second and see if we like that. Oh, no, 30 would be less steep. We want to make it more steep, so let's say instead of 45, we do something like 55, or actually a 60 degree. I like, because, there's, what, a 30, 60, 90 triangle? I don't know. Try to stick with units that kind of... Right, so we could do that. That's going to be a sturdier design, and then also... It also looks more like a 6'9" that way. And we still got this line. It's not a 45 anymore, but this line here still goes straight through the center point, right? Which is awesome. Yeah, I think I'm going to do that, because I'm looking at other zodiac symbols, right? Like this zodiac symbol, there's a nice big gap between the tip of the 6 and the 9, right? So Cancer zodiac symbol. So let's go look at the Cancer zodiac symbol and see what other renditions there are. Well, this one, it's pretty close, right? This one, closer. This one, they're just touching, right? This one, they're touching. So I guess the distance between the circle, this distance doesn't look too important. Like that distance can change, and you can still say, oh, it's a 69, it's a Cancer symbol, right? Yeah, or this distance right here, this distance is very close. Or this distance is very close. Somebody put it on a medallion, so they thought about it pretty hard. This is also pretty close. Looks like it's done in like an Arabic kind of script. That's kind of close. More geometric, which I like. This is kind of far away. This is close and far at the same time because of the tapering. Okay, so we're going to say doesn't matter. Does it look good? Does it look good? Does it look good? That's the question. Does this look good enough? And I think it looks good enough. I think it looks fine. I think we've created this geometrical symbol. And I'm glad we thought about it a bit, because it turned out easier to make after we thought about breaking it down. And because of that, I think before I go on to the next symbol, also I need to make the cutting files first. Before I figure that out, let's take a break to go to Leo symbol. So if we look at the Leo symbol, and we look at the images from this, can we look at enough images of this to derive the geometry that's happening? So we kind of see circle, circle, right? And I kind of like this kind of design, because I can see that it almost looks like circle and another circle, right? And then there's some type of tangency, and then there's a line, and there's a circle. So there's really like 3 circles. Like if we wanted to, now I like this a little bit better, because I like 2 circles that are the exact same size. This has been cut here. So this one was done in a very geometric fashion, probably done with like some type of computer generation. This one was probably made with primitives. That's what I want to do. I want to do one with primitives. So this is kind of that one right there is probably the way I want to go. So let's go put that one over in my other editor, in my other browser, for reference, because I think that is what I'm going to use. I think that the geometry for that just makes sense. Now, so let's go Leo symbol. Let's go look at some more images and see if there's any other structure that we can derive here. Because there's definitely some type of structure that we can derive, and we want to just derive something that is the most structurally simple, right? Where the math just makes it work. Now this is nice. I mean, it's a little bit different from what I'm seeing in other things, because everything else has this kind of curve inward, right? This kind of curve here. So this one also is kind of geometric to the point where it's like I kind of want to open this in a new tab and keep this one for reference as well, because it looks to me like when I look at that, I can kind of tell I can see the underlying structure, right? I can see the underlying structure in that one as well. So I'm going to keep that one for reference as well. Yeah, so this is an outlier in terms of the stylization. We don't want outliers. We want kind of like the most commonly accepted version of the symbol, right? So this is kind of good, right? But we get this. So there's definitely small circle, big circle, small circle, right? This is always the smallest one. This one looks like, oh, this one's a medium here. Right, or small circle, slightly bigger circle, right? So we want something with contrast thresholds. This one is kind of circle. This is just a weird Q, right? This is a weird Q, right? Some of these just look like weird Qs, right? Like an upside down Q, right? Because if we flip this around, right? So if we took this and just rotated it, you can see that this part is a Q and then it just has a big long tail on it, right? So I don't think we want to draw it as like a Q. We want to draw it like, see, upside down lowercase q with a really long tail, right? I don't think I want to draw it that way. I think that the other explanation for it, little circle, big circle, and a tail. I mean, I guess I'm saying the same thing, but this doesn't look as much as a Q. So some of them look more Q-ish. I don't know if I really like that. Now, I like this. That looks kind of good. But maybe I just like it because it's sparkly, and maybe that's more the upside down Q-ish. It's because this tight taper here I don't quite like. But then this kind of looks a little bit too ugly. This looks kind of fat. This looks like too tapered. This doesn't look like it's contrasty enough, and not because it's blurry, but the shapes don't contrast very well. This looks too bulky. And that could just have to do with the line thick. Yeah, that might have to do with the line thickness. So this is too stylized, too much taper. We don't want to do something like that just because it's hard. This I don't want to do at all. This is probably the worst because it's just like, ooh, draw a circle and then attach a squiggly, and there's no consideration for tangencies here. So that's out of the question. This looks like a paperclip almost. There's like a little, like you could see this like a keychain has a little spiral. The spiral of metal on your keychain, right? This looks like one of those keychain spirals, and then it just has some random hook attached to it. Like I could see this made out of like a metal, right? So okay, so I kind of see what's going on here. I know I want two tangent circles at a certain degree, and then I want the line at the same degree as well. So what do I mean, two tangent circles? So let's look at this design here, which I picked out, that I think is the best, right? So these two are pretty good explanation. These two are pretty good. But this looks kind of weird because, like, you see this extra line? There's, like, extra detail in here that doesn't need to be here. There's superfluous detail, right? So there's this circle and this circle, but you see there's, like, a little line joining them. There's a line rather than a tangency. And here, we don't have that line. We just have circle, circle, right? It's completely tangent. And then whatever degree is here, whatever degree is between this circle and this circle, should be the exact same degree of this line. And I don't think that's true here. I think that what we're seeing is the degree here, if this is our 0, 0, the degree of this line is slightly steeper than the degree from here to this center. From this center point to this center point, this is like maybe 45 degrees, and this looks like 50 degrees or something, right? So this is steeper. This line here is steeper than the implied line between both of these, and we don't want that, right? I don't see any reason for that not to be like that, right? We want to get rid of any superfluous details and make as many happy coincidences as possible. So. But it's as geometrically that's the best in terms of geometric perfection. That is the best one I have seen so far. So we'll kind of stick with that one as a reference guide. Okay, so we have this thing here, right? So we have made it. We've made the 69. So next thing we're going to do, we're going to get rid of the code that we were using for debugging, right, as we were rendering it. And we're going to go into the cutting file, and that was 69 is cancer, right? So we already got this already. So we need to open up one of these templates here, right? And just copy-paste code. So cancer would be CAN. So we'll just do CAN for cancer and save this in the cutting file as CAN001.scab. Save that. And then we want to make another one, file new, and cancer02, CAN002, CAN002.scab. And then we want to give those a run. So we're going to close this, and we're going to give the next one a run. So in our cutting files, we should have the cancer, right? So we're going to double click this, and it should just do kind of the same stuff as what we already had. Ooh. Unknown module, CAN001. So let's go look at the cutting file. Oh, ZOT cut cancer. Is that the same? Oh, because this needs to be refactored. CAN, this needs to be CAN, and this needs to be CAN, right? That was GEM for Gemini. That is wrong. Okay, so now zoom extents and render that, and then file export as SVG, and we're just going to call it CAN001.svg, and then we're going to open up the next one, right, CAN002, which is just going to be that peg pattern, right? It's not going to be anything revolutionary, right? It's just the peg pattern that goes on the bottom. And we're going to export as SVG, and we're just going to call it CAN002.svg. Okay, so now we have that out of the way, and the cool thing is, you know, looking at the symbols a little bit to analyze them, I think really is helping us, because the Leo symbol doesn't look too hard now, right? And after the Leo symbol, Virgo and Scorpio, Scorpio, and Capricorn look like the hard ones after that, right? Pisces is easy, Aquarius is easy. We're just going to do like squigglies. Yeah, so we'll just keep on keeping on, and we'll get to the next one. So it's taken us about 45 minutes to do each one of these. So it's nice little work sessions. So yeah, we're going to also, we had some images. So let's Aries, Gemini, Taurus. Okay. And Aries, Gemini, Taurus. So Cancer is the one we just made. So let's take the Cancer, right? Let's take that, and let's go snip that, and put this into our archive of screenshots, right? So we don't really care too much about the perfection of this. We just want to get it there. That's good enough. And then File, Save As, and we just want to save it in the root of the root, so that we know, so that we kind of know what's in here. Okay. Close this, and then also let's go back here and let's just open up this in a slideshow and kind of present what we have so far. So there's that Taurus, wait, not Taurus, sorry, Aries, because it's a ram, 69, which is a crab, which is Cancer, Gemini, because it's twins, or two, and this is our bull, which is Taurus. So Taurus and Aries, I kind of keep getting confused. But yeah, so they're all kind of like relatively the same size, right? Because they all have to fit into this circle, which kind of helps us make sure that we keep everything the same, except for this kind of looks like maybe it's, this one looks like it's the smallest in terms of size. Oh well, I guess. We do what we can do to keep it all in a nice little circle. And you know, but even though when I'm looking at the other things, Taurus is pretty small relative. Yeah, they're not going to worry about it. We got some nice little zodiac symbols. Let's keep on doing this, but first we're gonna stop the stream and do another one later. And I hope that I numbered this right, because I don't know if I did. Yeah, that's not the right number. In fact, this should be... This integer ID is wrong. This is... I guess I'm just not going to delete it, but... 188, 189... That should be 189. This should be 189. This should be video 189. I screwed that up. Yeah, it's video 189 right now. That sucks. So I guess we'll just keep this because this was the whole process. So not a fan of that, but the integer ID is wrong on this. That sucks. We need to do better, but oh well. Okay, and I'll be back later.